We have 2 chapters left to cover. They're short and they go together, so we'll cover both of them this week, which means there's 2 homework assignments and a group assignment, and then that's it besides the final. I wasn't sure which way to do it. I was
that and then Wednesday chapter.
the other one.
Yeah.
Okay.
For the last group assignment.
Yep.
I still want to
Keep it together. I wasn't sure which way. Like do 12 and 13 today and then the homework on Wednesday, but
yeah, that one was pretty short though.
yeah, they are. And wow, already. Next week we review for the final. I don't know. I changed some stuff around with the final. It needs to be like cover everything. But I decided for the in-class to only cover the new material. So there's only 6 questions on the in-class. Yeah. So then the take-home's comprehensive without the new material. But I had to cut out problems then, because I think I used to have 15 and 15. I did stuff around. So the in-class portion of the final will only be 11, 12, and 13. 6 questions. So I think it'll be short and shouldn't take more than an hour, but you have 2 hours. Your final, May 5th, 10:30 to 12:30 in this room. So it's not a regularly scheduled time. Most of your finals will not be their regularly scheduled time. Regularly scheduled time is a Monday at 8 a.m. would be Monday. Tuesday at 8 a.m. would be Tuesday at 8 a.m. But after that, night classes should be the same time also, after 5. Any questions on that?
12:30, 1:30.
Or take home is due before that. So next week we'll review for the final. Any late work I will accept until May 4th, 11:59. I can't take anything after that. Exam for the take home portion is also due May 4th, so Thursday night. Don't wait till Thursday night because you want to study for the exam.
Like a few days leading up to the Friday of the exam, where do we do then? Same like review or?
Yeah, we're gonna review. Wait, no, you mean finals week we don't meet. Yeah. So the last week we meet, other than the in-class exam, is next week. You don't go to any of your classes during finals week. You only go to your finals. Now, if you have a night class, and my daughter has a class 5:15 to 8 o'clock, that class meets. It's only once a week, and the final then is at that same time. That only works for night classes. If you want a final exam schedule, just Google YSU final exam schedule, and they'll come up. Make sure you put the right year in. And it shows you when you should be meeting. Now, still listen to your instructor. They cannot change this unless they get an okay from every single one of the students. But still see what your professor says. But like an 8 a.m. class that meets on Mondays, the final is Monday at 8. A 9 a.m. class, the final is Wednesday at 8. A 10 a.m. class, Friday at 8. Our class is 1, so it's Friday at 10:30. And then this side is Tuesday, Thursday classes. And then night classes, it says something about they meet when, that's fall. Forget. Well, they do have finals marked. They might have changed it since, I haven't had a night class in a very long time. Any questions? But today, 14th week, 2 weeks to go. Chapter 12 and then 13. If you need more work or want, I might have explained things differently. There might have been questions, but there's videos here. I think these ones are from my YouTube channel, this one. And then, well, these are the classes, but. Is that the right one? Oh, there it is, outline. So I've talked a lot about this already, independent events. So far, they've been independent. For instance, when you roll a die, we have our probabilities. Each of them comes up 1/6. But when we roll it again, it doesn't matter what we got the first time. Our probabilities don't change. However, if we had a deck of cards, if we pull out a card, we pull out King of Hearts. If you don't put it back in, now you only have 51 cards and you don't have the King of Hearts, so you've changed the probabilities. That's dependent. The second one relies on what happened the first time because now I've changed. I don't have all the cards in there, and I'm missing the King of Hearts. So an independent event, one event doesn't change what happens the second time. If I toss a coin and get a heads, rolling a die, it's not going to affect it. So they're independent. If you have a jar of marbles and you pull out a red one, if you don't put it back in, now you don't have as many marbles. You're missing one of the red ones. I've changed the probabilities for the next time. Any questions on the difference? So if you need to explain independent and dependent events, we're good with that. With independent events, can find each probability and multiply them together. For instance, if you're tossing a coin and rolling the die, you can find the probability of whatever you're looking for, maybe a heads and an even. You can find them separately and multiply them together. And that's what this is telling you. So it's good to know if your events are independent or not, because then you can find the probabilities of them separately and multiply them together. If we toss a coin and roll a die, the two events are independent. One doesn't affect the other. If we do that, how many outcomes are there? 6? How many? Yeah.
36.
Okay, so what, yeah, when we toss the coin, there's two outcomes. When we roll a die, there's 6. 2 times 6, there's 12 outcomes. Now what we're going to do, we'll do it one way by listing all the outcomes, and then I'll show you the probability by using the rule where you just multiply them together. So if we list all of them, tossing a coin, we can have a head. Rolling a die, we could have a 1, 2, 3, 4, 5, and 6. Or we could have tossed a tail with a 1. That would be all 12 outcomes. Any questions on that? When you list your outcomes, then it's kind of easy to see what's the probability of a head and a 4. There's only one of them, so 1/12. How about the probability of a head or a 4?
6/12.
Okay. A 6 would be all of the heads. But since it also says a 4, we would also include this one. So it would be all of the ones on top because they're all heads. And then it said or 4. Now we wouldn't include this one. We already counted it with the heads. So it would be 7. Any questions on that? Like I did, I skipped one. No. Okay. Example, toss 2 coins. How many outcomes do we have?
4.
Wait, how many outcomes are there?
4.
Okay. Because when we toss the first coin, there's 2 possibilities. Tossing the second one gives us 4 outcomes. What's the probability they're both heads?
1.
Because there's one case where they're both heads. Any questions on that? Now you could list them all. What's the probability of one is heads and one is tails? The way this is written, it doesn't matter. Now, if they said the first one's a head and the second one's a tail, then it'd be different. This one's just like, excuse me, that we have one head and one tail. Which means then there's 2 cases. Because we could have the 2 heads. The first could be a head and then a tail and then a head, or the 2 tails. If this didn't say a head's first and a tail's second, then it would only been 1/4 because there's only one of those. but this just said one of each. Any questions so far? Toss a coin 10 times. How many outcomes?
Just 20.
You said 20? Well, yes, but it's 2 times 2 times 2. Because we're gonna take 2 times 2 times 2 times 2 10 times. If we're gonna keep tossing that coin, and each time we have 2 possibilities. So there's 1,024 possible outcomes. What's the probability they're all tails? How many ways can it all be tails?
Is it 1 over?
Mhm. There's only one way to get all tails. Because each time you toss it, you have to have a tail, so it's only one possibility. Now, if you divide it, it's highly unlikely. I rounded. Questions on all tails? So if we wanted to find the probability, it's not all tails, there could have been one head in any one of the 10 spots. And then there could be 2 heads in all the different spots in the 10, the first 2, the first and the third, the first and the fourth, so on. It could be 3 heads in all the different positions, and so on, including. When there's a lot of different possibilities, remember the complement? This includes everything except for this. And they have to add up to 1. So we can take 1 minus, if you want to use the fraction, or the decimal. $89.9%. Any questions on that?
So we moved the decimal, got it at 13%.
It is not a percent. So if you want to make it a percent, you have to multiply by 100. So it'd be 99. This one wouldn't even be whole. 0.1%.
So for not all, you're looking for a percentage answer.
Wait, say that again?
So for like not all tails, you're looking for a percentage answer? Or I did 1,023 over 1,024.
That would work also. Now, in some cases, I might ask for the percent. Did we talk about like the one team that won so many coin tosses in a row? Something like that, I would have you put it at a percent because it's a little easier to see, although 1 out of 100, even odds would be good. Like the odds of all tails. The odds of not all tails. So there's one way of getting all tails, there's 1,023 ways of getting something that has a heads in it. So that would be 5. I would probably either ask for odds or the percent. I'm not sure, I forget. There's one on the test, I know. No, I put one. Here it is. It's the probability of losing, right, as a fraction and a percent. So on the test, I asked for the fraction and the percent. This one, when we make it a percent, not even full percent. You might, I don't know what I'd have you rounded, but 0.1%. So on the exam, you're asked for a fraction. I think I had odds in there too, but it got so small, I took it. Any questions on that? Any questions? These are practice problems. We spin both spinner above. So if we spin one spinner and then spin the next spinner, are they dependent or independent events? Wherever this lands isn't going to change this one. They have nothing to do with each other. So they are independent. Go ahead and find the 3 probabilities. I don't notice the next one. We're just going to change that number since we just did 10. We'll just change it to a 12. Oh, that's a die, not the coin. We could leave 10. It might work out better. Now, these events are independent. Because they're independent, you can multiply them together. So the probability of south and odd is equal to the probability of south times the probability of odd. Or you can write every single outcome. How many outcomes would there be?
32.
There's 4 here and there's 8 here. 4 times 8, 32 possible outcomes. So we could write all 32 down if you wanted. It would be north with all of the numbers, 1, 2. Well, some of them repeat, so it's going to be a little different. It's harder to list because there's 1, 2, 3 ones. So the probability would be easy. For south and an odd, what's the probability of spinning south? 1 out of the 4. What's the probability of spinning an odd? Multiplying across, it's 5 over 32. So when they're independent, rather than trying, because you'd have a north with 3 ones, a north with 2 3s, it's easier if they're independent to find them this way. Do each one separately. Probability. So go ahead and find the next 2 now using multiplication. So for probability of east, are you getting 1/4? And then what's the probability of a 2? Multiplying across. And you don't have to reduce. I get more mistakes seeing students reduce than just leaving the probability. So probability east and 2, did you get 2 out of 32? How about probability not north and not 1? What's the probability that it's not north? And what is the probability it's not 1?
5.
8. 15 over 32. So when things get a little large, for instance, 32 of them, you can try and find other ways to get them to work. Any questions on that? Number 2, this would be similar to the coin, except we're rolling a die. So go ahead and try that. Roll a die 10 times. Well, first, is it independent or dependent? Mm-hmm. Because each time we roll it, we still have the 6 sides of the die. How many outcomes are there? Anyone? Oh, no. Okay, 60 to the 10, or 6 to the 10. There's 6 outcomes in each roll. We're doing it 10 times, so it's 6 to the 10, which is 60,466,176 outcomes. Yes.
Is there a problem that mixes two things, like if we're doing it 10 times, so you multiply and you do an exponent?
For dependent ones,
Like if you flip the coin and roll the dice 10 times.
I probably wouldn't do that to you. But if I did, if you were tossing a coin and rolling a die 10 times, it'd be 2 to the 10th times 6 to the 10th. Yeah, you would just do each of them separately because they're independent.
You multiply both.
Yeah, you'd multiply them both together. Although rolling the die 10 times is pretty large. Well, it would just be taking that one. Let me see if I can bring it back up. Times, wasn't it 1,024? Um, 6 times 10 to the 10. $62 billion. But I know I didn't ask that. I like doing the tossing of the coin for so many wins or losses from a team in a row. Because it's, I think it's kind of interesting. It's fun to bet on. What is the probability when rolling a die 10 times that they are all ones? We know the possibility. There's only one case where they are all ones. So it's 1 divided by 6076. And it's really too small to look at it as a decimal or a percent. Remember, odds for them all being ones, there's only one case. And then against would be 60466,175. Because this is the total cases. You have to take this one out to make it an odd. Remember, odds, they should add up to your total, and the total is our denominator. Any questions on that? Probability of pulling 2 cards from a deck of cards. Is it dependent or independent?
Or, it doesn't really say you're putting them back.
We kind of need a little more information, yeah. Now, if we're just pulling 2 cards right away,
Then put them back here.
if we pull 1 card and then put it back and pull the second card, it's independent. If we just pull 1 card and then pull the next one, it's dependent. The second one, the probabilities have changed. So I would give more information or ask you to explain each case. So for this one, I would think you should explain. If it's dependent, then we didn't replace the first card. If it's independent, then we would replace the first card so that all 52 cards are back in there before we pull the next one.
So explain both scenarios.
Yes.
So the first scenario is if you pull 1 card, the next one will be dependent, but we're just pulling both of them.
Right, if you don't put, say we pull a king of hearts, if we don't put that back in, now when we pull the next one, 1, we don't have a king of hearts, and 2, we only have 51 cards, so we've changed our probabilities. They're no longer out of 52, they're now out of 51, and if you're looking for the king of hearts, it's not going to be there. So you're changing your probability by not putting it back in. Okay. Now, there are cases where you can still multiply them together, even though they are not independent. You just need to be careful. For instance, if we pull a card from a deck of cards, we write it down or set it down, don't put it back in, and then pull a second card. So when we pull the first card, what's the probability it's a king?
4.
There's 4 kings out of the 52. Now, once we pulled that out, we no longer have 52 cards. We have 51, and we're missing a king. No, I put, what's the probability the second one is an ace?
That'd be 4/50.
4/51, exactly. So now there's only 51 cards, but there's still 4 aces in there because we pulled out a king. Probability they're both kings. Do each probability separate. So the probability the first one's a king, we knew that's 4 out of 52. Now we have 51 cards and one of the kings is missing. What's the probability the second one is a king?
3/51.
Because now there's only 3 kings in there out of 51 cards. So even though they're not independent, if you're careful of what's left, because you're not putting it back in, you can still multiply your probabilities together. You're just not finding them completely separate. You're realizing that it's changing your probability. Any questions on that?
So the answer to 3, the original question, if it's dependent, the probability is 10.
For this, if they're dependent, then you're not replacing your first card. So you're changing the probability. To be independent, you're putting it back in so the probabilities stay the same. Any questions?
So there'd be no probability that it's not, we're not told the cards to draw?
In this case, yeah. It was just seeing if you understood dependent and independent.
If you do 1/52 times 1/51.
Depending on what, we don't know what we were looking for though.
Okay.
And that's why I gave you 2 examples. Those 2 examples are not replacing, so they are dependent.
Oh,
What part?
dependent, breaking that down, yeah. Because it's such a small part of this outline.
Yeah.
Probability practice. It might be on home.
It's definitely on the homework.
Yeah, probably.
I didn't look at it real good. I was just switching things around, but, I know I have it. I think I have a deck of cards. We're replacing it. That's all I'll tell you. Yeah. Now I'll go switch it. Yeah, I know that probability is not everyone's favorite. So I try and keep it as minimal, but it's my favorite. Okay, so we have, if we are pulling marbles from a jar above, what do we need to know to keep the events dependent?
Not replace.
Mhm. Yep, each marble you pick out, you would not put it back in, so then the jar changes. Keep it in. We have to put the marble to the jar every time to keep our probabilities the same. So to make them independent, to make them dependent events, we keep the marble out, because then it depends on if you picked a green, a blue, a yellow, orange. So by keeping it out, it makes them dependent. We want them independent, we put it back in, so then the jar stays the same each time. Any questions on that? You have 3/4, 5 dimes, 6 nickels, and 6 pennies. If you're pulling one coin from your pocket, setting it on the table, and pulling a second coin and setting it on the table, is that dependent or independent? Right, because the amount of coins in my pocket are changing, which is changing my probabilities. Go ahead and find the two probabilities. So they were dependent because we're keeping the coin out of the pocket. We're not putting it back in. So it changes how many coins, it changes all the probabilities. What's the probability that the first coin is a quarter?
3 or 1.
So that means we pulled one of these quarters out. So now there's only 2 quarters, 5 dimes, 6 nickels, and 6 pennies. Give us 19 coins. We've changed all our probabilities. When we go to pull another one, what's the probability it's a dime?
5/19. Yeah, 380.
Monday, never do multiplication in your head on Monday. Did everyone get 15 out of 380? Any questions on it? Give 2 cents. How many ways can we get 2 cents when we pull it out of our pocket? Well, it doesn't have to be at once, but we need to get a penny and then another penny. So they both have to be a penny. What is the probability that the first one is a penny?
20.
So now we still have all our quarters, but we have one. What's the probability that the second one is a penny?
I don't know.
Any questions on
So we can pull them both at the same time or one. Probability.
that? Right, if you pull them both, as long as they're the same coin, if you pull them out both at the same time, you still could figure out the probability, but you'd want to do it this way. Any questions on that? Any questions? So those were the outline. The homework. I think it's better to do homework first because the other one is completely different. It's contingency tables. So we'll say Wednesday for contingency table.
Oh, let's check the routine.
Mm-hmm. I think it's interesting. It shows you about different tests, like strep throat tests, they use a contingency table for it. COVID, they use contingency tables for it. Candy causes violent crimes. There's a contingency table. But we'll do that. All right, determine whether the scenario involves, this is homework, this is for a grade, 28 points due on Sunday. But of course, we're gonna do it now so you can get it turned in and not have to worry about it. Okay. Determine whether the scenario involves independent or dependent events, and you can just circle which one. We'll do the first two and then we'll do the second two. So go ahead and do the first two. So the first one, you flip a coin and roll a die. The coin lands up heads, the die shows a 1. Is that an independent or dependent event? Yeah, because flipping the coin head or tail isn't going to change my roll of my die. So it's independent.
If I'm flipping it,
When we flip the coin, the head or the tail, in this case it said heads. I got these offline. But even what we roll doesn't matter. When you flip a coin and roll a die, they are independent. They have nothing to do with each other. One will not change the other one's probability. A box of chocolates contains 5 milk chocolate, 5 dark, and 5 white chocolate. You randomly select and eat 3 chocolate. The first is milk chocolate, second is dark, and the third is white chocolate. Is that independent or dependent? Yeah, because if we find the probability of the milk chocolate, now one of them's missing because we ate it, it's going to change the probability for the next ones. And so they depend on each other. One depends on what happened in the one before.
So, you know, if you grab 3 all at once.
If you want to find the I think
is
it,
that independent? That's how I took it.
if you grab them, If you grab all of them at once, then you gotta look at all the different orders that you could have eaten them in. I wouldn't do that. That would be a hard probability. But this one says the first piece is milk chocolate, so you're taking one at a time. And since we're not putting it back in, they're dependent. Okay, go ahead and try the next two. Okay, number 3. A bag contains 8 red marbles and 4 blue ones. You randomly pick a marble and then pick a second one without returning the marble to the bag. The first is red, the second is blue. Is that dependent or independent? Dependent. Since we're not putting the marble back, it's changing the probabilities. Any questions? Is that what everyone got? Okay, for the fourth one, a cooler contains 10 bottles of sports drink, 4 lemon lime, 3 orange, 3 fruit punch. 3 times you randomly grab a bottle, return the bottle to the cooler, mix it up. The first time you get a lemon lime, the second and third time you get fruit punch. Would this be independent or dependent? Independent, because we keep putting it back in, so then there's the same number in there every single time. There we go. Any questions on those two? So the fourth one was independent because we keep putting it, it says grab a bottle, return it, and mix them up. And you flip a coin and then roll a fair 6-sided die. Go ahead and answer the questions. Now, a lot of times on a test, I might do something like this. Depending on how many possible outcomes there are, I won't make you write all of them. I might ask list one of them. One outcome, flipping a coin and rolling a die, could be H5. Especially rolling 2 die, there's 36 of them.
For these, does it say show work? What's that?
This one,
Okay. And then, what is sample space, be okay for showing work?
yes, that's one possible way. There's probably Everyone have that one done? So if we flip a coin and roll a die, dependent or independent? Yeah, we've talked about that one a lot. They have, one does not change the probability of the other. So they are independent. How many outcomes are there? There should be 12, because the coin has 2 heads or tails, and the die has 6, which gives us 12 outcomes. So look at each space separately. List one of the outcomes, and I had said one. You could have a head or a tail, so H or T, and then a number 1 through 6. So a heads and a 5 would be one outcome. Any questions on that? There's a couple ways that you could find it showing your work. One way was mentioned with the sample space. I'm just going to draw it on the board. It's fast. And I think I wrote this earlier today. Can have a heads and a 1, heads and a 2. Or we could have a tail with each of them. So we could list our sample space, and then we want to find the probability heads and 3. Says and. And or are different. You need to be careful. How many are there where there's a heads and a 3?
1.
1 out of the 12.
You just multiply the 2 outcomes together to get that.
You could do probability of heads when we toss a coin is a half. Probability of a 3 when we roll a die is a 6, which gives us 1. So either way would be showing your probability. Show the outcomes or show when they're independent, you can multiply them together. Any questions? Okay, go ahead and do I think it might be the last one. Nope. Number 6. Do you agree that rolling a fair six-sided die twice is independent? Yep. One doesn't change the next one's probability. How many outcomes are there?
56.
Does everyone agree? Yeah, there's 6 with the first die, 6 with the second, 36. What's one possible outcome?
4 and 5.
A lot of possibilities, actually, 36 of them. So we get a 4 and a 5, a 5 and a 4, a 1 and a 6. Any questions? What is the probability? The first one is a 5 and the second one is even. Did we list all 36 of them?
Yeah, that's 3 and 3.
Probability 5. Probability of a 5 is 1/6. Even, there's 3 of them. Now, if you wanted to do like listing them, but you don't want to list all of them, you think about the sample space. Would be a 1 and a 1, a 1 and a 2. And all the ones first. And then a 2 and a 1, a 2 and a 2. 3 and a 1, 3 and a 2. But really, we only care about, it has to start with a 5, because the first one was a 5. So we could go 5, 1, 2, 5, 3, 5, 4, 5, and 5, 6. We really only need this row because we know it started with a 5. The first was a 5. Then we want the evens. The 5 with an even is 3 out of the 36. So you don't have to list the whole thing. We knew it started with a 5, so we could list this part of it and see that there's 3 of them out of the 36.
Would you ask us to write out the samples?
If it's small enough, I might ask the sample size. I don't think I would go larger than the heads with the die. I would not ask all 36. Any questions on that one? Okay, go ahead and do number 7. Okay, there are 8 shirts in your closet. 5 are blue and 3 are green. You randomly select one to wear on Monday, a different one on Tuesday. Independent or dependent? Because you're not putting it back in since you're wearing a different one the next day. How many outcomes are there? Well, no, there was 8 shirts, but I pulled one out and wore it. So now there's only 7 the next day. Yep. What's one of the possible outcomes? Anyone?
Monday, Tuesday.
Blue both days. Blue, green. Green, blue. Any questions on that? I guess there's only one more, green, green. What is the probability you wear a blue shirt both days? Well, I listed all of them. But I didn't put the probabilities. They're not all equally likely. So just listing outcome in this one doesn't help them. Because there's 5 blue ones and 3 green. They're not equally likely like the dice or the coin. So this one would be hard to do listing all your sample space unless you put the probabilities with them. This would be easy. The probability of a blue than a blue. What's the probability that the first one is a blue? Now we pulled one out, so there's only 4 blue, 3 green, and 7 shirts. So what's the probability the second one is blue? So drawing a sample space is a little hard when things are not equally likely. And that's why you would go with this one. Any questions on that? One more. Go ahead and try number 8. Excuse me. So we randomly select one piece of fruit and eat it, then we randomly select another piece of fruit. Independent or dependent? Because we're not putting it back, we're eating it, it's changing the next probability. How many outcomes are there? Not sure. The first one, there's 13 to choose from.
Would it jump down to 11? Well, no, I mean,
No. It would,
13.
well, because we pull the one out and eat it, there's 12 left, and then we pull another one out. $156. What's one possible outcome? Would be one of the fruits, so apple or peach. And then another one of them. So a peach and a peach, an apple and an apple and a peach, or a peach and an apple. Any one of those possibilities. Any questions? And there's 156 of them. What is the probability the first piece is an apple and the second is a peach? So we have 6 apples and 7 peaches. What's the probability the first one is an apple?
6 or 13.
Now we ate that apple, so now there's only 5 apple and 7 peach for 12 pieces. What's the probability the second one's a peach?
7 over
42 out of, was 150, oh, I wrote it, I'm sorry, 150. Any questions? Okay, I don't want to start chapter 13 today. But if you have questions, stay and I will help you. But if you do not have any questions, I will see you on Wednesday. And don't forget, this was the homework. Make sure you turn it in. Okay, did it click it out? Okay. If you do not have any questions, those who are online, I will see you on Wednesday. I write my notes on it so I can go back to study it, but you mind if I turn it this way? No. Okay, thank you.